Hey everybody, welcome to MySec here at GRCC in Grand Rapids. My name is Richard. Happy to introduce Colby for tonight's presentation today. Just a few things to say real quick though. Just as a reminder, we have GrrCon coming up later on this fall. If you haven't gotten a ticket yet, take a look. They're going to sell out most likely again. They might release more tickets, but we'll see. All the early birds sold out in 15 minutes. That's how popular that conference is. So hopefully you can get there and I'll see you there. Beyond that, I know MySecCon is hopefully still going to be a thing later on in the fall, so I look forward to more information about that. So we're a subchapter of the greater MySec organization here in Michigan, and I believe they're also looking for more people to join the board of directors if that's something you're interested in doing at some point. Without further ado, Colby.
Thank you, Richard. Cool. Glad everybody can make it tonight, virtual and in person. Tonight we're going to be talking about TrueNAS Community. It was recently renamed as of the release that came out this past week, actually, and we'll go from there. Just a little bit of who I am. I moved to the Grand Rapids area 5 years ago. 4 years and 11 months. I currently work for Dell on a really big services contract. If you know me, you probably know who it is. I work in the primarily I work in the IT AD space, which is asset disposition and acquisition process. So if you have questions about how disk wiping or to deploy a computer or lifespan of a PC, I've been living that space for about 20 plus years. I'm on LinkedIn, right there. I was trying to find I wouldn't say embarrassing picture, but just a recent picture that I sent to my wife. And so there was that. If anybody has any questions, please speak up. What we're going to be doing when I was developing this, I was remembering a conversation that we were having a few weeks ago over technical discussions in presentations and the assumption of existing knowledge. And often there's a presumption of knowledge. And so I didn't want to assume that. So what we're going to talk about tonight in TrueNAS is is very high level because it can get complex very easily. And while I've been using it for a few years, there's a million things that you can scratch the surface on, and you're never a master of any. So what is TrueNAS? Probably wondering, just basic aspect of it. It originally started as FreeNAS, actually, in FreeBSD. And that had been around for about 15 years. And the company IX Systems is the maintainer of it. And for the longest time, FreeNAS became core, or what's known as TrueNAS core. And that's currently still being supported. It's no longer, they even came out and said we're not going to actively develop for it. If you're an enterprise customer, we'll support you. If you're a home user, we really suggest you to migrate to community. This is, I think, the one slide I didn't update Scale. So Scale is based on Linux, or actually community is based on Linux. It's based on Debian. Because this is an appliance, what they do is they disable apt. And you can re-enable it if you want at your own discretion. You can sideload drivers and things of that nature. Again, when you upgrade, you're on your own at that point. But they've been doing a better job of running more current Linux kernels, so you get better driver support, especially for GPUs now. They include an NVIDIA driver. They include an Intel Arc driver. They're working on including a AMD driver. So when you run containers or run virtual machines, you can pass those devices over. More to the point, what TrueNAS is a user interface, much needed user interface into ZFS. And we could talk about ZFS till the cows come home. We're going to touch on it very lightly because TrueNAS can do a lot of things using ZFS. And if we want, we can go a little deeper into ZFS, but not a whole heck of a lot. It can run virtual machines. It can run Docker now. So before it was running Kubernetes, it's now running Docker, and you can actually bring in your own Docker config files from scratch if you want, and so all that good stuff. Minimum recommendations are very easy. 16 gig SSD, and specifically, you don't need when you install it and you use it, the boot drive is only used for booting, for containing the actual appliance and the configuration. No data is actually stored on it whatsoever. The cool thing with ZFS is that you can create a ZFS pool in here. And if you're like, you know what, this isn't, TrueNAS isn't for me, you can take your pool as is to a Linux system, to a FreeBSD system, to even to a Windows system, import the Z pool, and all your data's there.
Even on Windows?
Windows has experimental ZFS support now.
Oh.
And so you can run it with probably less than 8 gigs of memory. Really probably wouldn't recommend it. But even with like a 16 gig drive, boot drive, would not recommend a USB drive because you're going to have a ton of read and writes to it. What people like to do is use those really small Optane drives that were common a number of years ago that Intel had for like just caching on consumer PCs that were like really inexpensive. Those are really common. So community was, so when they developed, so Scale was the way to get out of FreeBSD into Linux. And essentially what it meant is that it enabled them to scale up and scale out. But the hilarious thing is that to do clustering is that they had leveraged Gluster, and Gluster basically doesn't exist anymore. So they haven't actively said what they're going to be doing for clustering support in the future, but for the most part, it seems like they're going to go with Ceph. So you won't have ZFS, you'll have Ceph disks. It'll just be an easy to use interface instead of what Ceph has to offer today. And you can even virtualize it. So the cool thing is you don't have to have a dedicated machine. A lot of people in the home lab community, what they'll do is they'll just create a virtual machine, throw some disks, you can either create your own virtual disks, or what's more common is people will pass an entire HBA or host bus adapter. So so to back up a little bit, ZFS doesn't like hardware RAID controllers. ZFS is software-based RAID that needs to see the entire disk, the raw disk, actually. And one of the things it does, it requires to be able to see the unique serial number of the drive, and it uses that to differentiate itself from all the other disks, but also to be able to run smart commands. If it can't run smart commands, it's not gonna like it. It might work, but you probably will run into problems down the line. You're looking at me, Jake.
I was going to ask, what does RAID stand for?
Redundant.
Array.
Oh, thank you. I can't even. Yeah, redundant array of independent disks. Independent or inexpensive. It's usually independent. So.
Can I just ask?
Yeah.
It might be useful just to go one level higher.
Okay.
What is NAS, and what is the goal of this software pack?
Okay.
The high level goal here.
Sorry. Thank you. NAS being network attached storage. So You want to create an SMB share, you want to create an NFS share, create an iSCSI share, or you want to run Plex or anything of that nature. While you can run a Synology, you can run TrueNAS or any other open source software, and run this on your own machine versus commercial off-the-shelf software. Thank you. Installing TrueNAS, really simple. This is what it looks like. So the very first time you log in, it's pretty straightforward. You have your RAM utilization, you have help, you have what your IP address is, your CPU cores, all that stuff. You're like, okay, easy to read, easy to get yourself into. So what I was saying earlier, so when you start figuring out resources and things of that nature with TrueNAS, you'll look at your RAM. One of the really cool things that ZFS does is ZFS can do incredibly fast reads, and it does that by leveraging RAM. So what you'll see often is you'll see TrueNAS installs that have a whole lot of RAM, because the more RAM you have, the more it can take advantage of. So if you run a virtual machine in TrueNAS, it's sitting on ZFS, and if it's like something that's doing a lot of reading, it's going to be able to leverage that RAM. Or if it's like, say, like serving up your media library over a bunch of clients, it's continually reading the same files, it's going to be reading it from RAM. And so the more RAM you have, the better, but you don't necessarily need to have a whole lot of RAM. There was an old saying that you need to have a gig of RAM for every terabyte of storage with ZFS. It's not true. It's really not. I run it with 16 gigs of RAM with a 2 terabyte pool and a 25 terabyte pool. I don't do a whole lot of reads to it. I'm doing more writes to it for backups than anything. There are tools. You can leverage the reporting mechanisms to see where you may be deficient when you start going down these routes. When you create a storage pool, which we'll go through in a moment, they've made it very easy to be like, they step you through a wizard, we'll show it to you. It's very easy. It took a lot of the complexity out of it over the years and just made it way easier. Let's see if this runs. Yeah, there we go. Oops. Oh, shit. Doesn't let me do full screen. I'm sorry.
Not like full screen.
Yeah. So, there we go.
So it wouldn't let you do full screen on full screen,
Right.
if you go off full screen, you do full screen.
Don't you love? So this is really straightforward. So over here you have your dashboard, your storage, your data sets. We'll talk about what data sets, and then your shares, your data protection network, all that. We'll go through all that. Really, again, at like a high level, you can spend tons of time in this.
So a pool would be a pool of storage.
Correct.
So a pool would be like a partition in a way.
No. So a pool is a series of disks. So you have one disk. You want to be able to use that disk. You have to create a pool. And then you want to create a share. Well, you just don't share the pool. You have to create what's called a VDEV. We'll talk about that in a moment. And then From there, you can then create a share. Because one of the neat things about ZFS is that for every data set you create, it's an individual file system. And so you're like, I need to create, I need to create a file share for a bunch of logs. They're not going to a database or whatever. I need to create a share that has only gonna share these like 1 megabyte log files. So you can create a data set where the file record size is on par to what your average file size is going to be. And so you have optimum file storage for that specific share. You don't have, you're not wasting a lot of extra space due to unallocated kilobytes that when you're dealing with something like that can add up and eat up a lot of space. And then on top of that, you can introduce additional, what they call special VDEVs that will help with expediting speed in some of those situations. Because when you have a lot of those, I know if you go to like a NAS and you're like, I want to look at this file share that has, say, 13,000 log files in it, it's incredibly slow to traverse it because there's so much metadata in that between the PC and the share. It's just having to really struggle with it. And special VDEVs can help with that. You can put that data on incredibly fast media versus like spinning Rust, basically. And so it's dedicated for that.
Gotcha. Thank you.
Yeah. Okay. Dang it.
So while you're on pools.
Yeah.
So those would be like physical hard drives you throw into the pool and then be able to use.
Correct.
The space.
Yeah, so what you do is
You have to get it on full screen to be in full screen.
Oh, God, what the? I'm sorry.
This is not like,
No, you're right, it's not. It's
The demo gods.
yeah.
There will be this one.
It might just need to be small for us to see us here.
okay. So first thing we do is when we create it, we can name it, give it a name, and then what we do is, so in this situation, I created 2 virtual desks. And so what you can do is, so you create the name, you establish a name, and then you have all these different options as to what you actually, the kind of pool you want to create. You can create a stripe, which is basically like a RAID 0. Take 2 disks, mash them together, have it be really fast with no redundancy. You can do a mirror, self-explanatory. RAID Z1. Now you're asking yourself, what is RAID Z1? That is ZFS with 1 disk of parity. That's what we would call traditionally RAID 5.
Oh.
Because you only have one, because ZFS makes the nomenclature a lot easier. You have 1 disk of parity. Why would you call it RAID 5?
Because that's what we were taught.
Yeah.
Exactly, I agree, I was the same way. So RAID Z2 is
2 disks of parity.
2 disks of parity. RAID Z3, 3 disks of parity. Obviously, every time you add additional disk of parity, you're losing that additional storage, but that's just your own, you have to figure out what's the best way for you. And now recently they introduced DRAID, which is another form of ZFS RAID that has that is quote unquote faster. You have,
But you lose the parity checks, from my understanding.
they what?
You lose like the ability to do like the like the deduplication and
Oh, okay.
compression of mainline ZFS.
Oh, okay.
from my understanding.
Okay. So it's like a fork of ZFS with less capable features.
But you triggers. those
Right,
faster.
with sacrifice. So if you feel experimental.
So
You said you have 2 disks.
Yeah.
here, right? So if you pick RAID Z3, you can still run Z3 on 2.
No, it won't actually let you. So like right here, it says unassigned disks. So you probably you might be able to select it. I honestly didn't try. I really hate this. It's like you have to do it in that specific order.
you get good at it.
Just use your mouse. Don't press any other button, just the mouse.
So what you didn't see before is, so they have an automated disk wizard now, or you can just go in and manually do everything. And the disk wizard will try to figure out, based on the quantity of disks you have, the size of disks you have, things of that nature. So like right here, it says, hey, we found this disk. So if you have disks that are of multiple sizes, what it'll do, so say like if you have like a 1 terabyte and a 2 terabyte disk that you want to make a pool of, you want to do a mirror of, you can do that. You're just going to lose that addition. It's going to use the lowest common denominator of space. So which actually works out well, because if you have like a bunch of like 1 terabyte SSDs and they're all different manufacturers, they're all going to have slightly different byte counts. Or it's more common in hard drives than SSDs. So right here, so what I touched on earlier, so log, what you'll see next is, so ZFS log is what they call a special VDAV, where it can speed up different performances, functionality of ZFS. I have never used it. I've never had a need for it. Oh, right. So this can actually synchronous writes. So earlier I talked about with your read cache. This will actually start to provide you a write cache. And what it does, instead of when you write disk, when you're writing data directly to the pool, it'll actually write to this special disk. It's usually a much faster disk, and then that disk sends data to the pool. It's a misunderstood function. A lot of people think that they can just shove something that's faster in there, but they actually need to get it tuned just right, where they actually do see a performance increase. And it's often people will see a decrease in performance because they haven't tuned it correctly, or if they're actually using it correctly, which is pretty common.
So I was just thinking about your automatic disk selection.
Yeah.
And so, I was thinking like if we have some slow spinners, like 400 RPMs, and we have some 9600 RPM spinners that are much faster hard drives, and we have SSDs, we could pool them each in their own pool so that there's
right. So you'd actually
slowing each other down.
Correct. You would. So you bring up a very interesting point. So when you start getting into thoughts of like, do I create one big pool? Do I create multiple pools? Do I create one pool with multiple VDAVs of various different kind of disks, or a pool for every kind of disk? These are the discussions that you have to figure out. These are the things that you have to figure out, either the community has figured out or you have to figure out.
Right.
If you have different speed disks, it's going to be advised that you actually put them in different pools, because when you write data to a pool, it's got to spin them all up. And if and you have a possibility of things getting out of sync, basically kind of like almost out of sync in a way.
Yeah.
Or one disk writes and then everybody else is waiting, and then the others are waiting, and then that can cause issues in the back end.
Right. So then also with, if you have like 250 gig hard drives, a few of those, and you have some 4 terabyte hard drives, you probably want to have those in separate pools as well, because of like the, where you were talking about, you lose space.
Yeah, and so you could actually, what you could do is you could put them all, that would be the best. That would be the best way, because ultimately when you go to upgrade down the line too, is that you can, when you're like, hey, either this disk is dying or I just want to replace it with a bigger disk, you can replace the disk as is and initiate what's called a resilver or a repairing, and it will do what it needs to do to rebuild that disk. And so say like you want to rebuild that pool. So say like you have a bunch of disks and you want to rebuild that pool to bigger disks to get more space, you do that one at a time. And then once the last disk is done, then all the rest of the storage is available.
Really?
Now,
Oh, that's cool.
it can be a very long process just because of what you're doing. And when you are doing resilvering or repairing a drive or a pool, it's recommended to actually like not do take that pool out of commission, because I think we've all been in a situation when you're rebuilding a RAID parity, you're stressing the drives that they've ever been stressed before, and that's when they can go back. And so if you just try to limit the amount of data that's being read and written from it as a whole from external systems, it's safer.
Thank you.
So that right here is a designated hot spare. So if you have instead of waiting for an alert to go in and swap it out, you can designate a physical drive as a hot spare to automatically do it. It's a nice thing to have. It's, the way I kind of look at a lot of this stuff for home labbing is make sure you always have a cold spare, so you never, it's like, it's an expensive thing to do, but at the same time, it's in the moment, it's you're like, I'm glad I'm thanking my past self. Right here is cache. So previously I had talked about ARC, this read-only cache. This is L2 ARC, which is the layer 2. So when you run out of L1 or your ZFS RAM cache, it reads from disk. Well, you can configure this to say, read from this special drive. So again, you can have a much faster disk, say like an Optane PCIe card in there, have that be your ZFS L2 cache, and be able to benefit from that, from faster reads. But what I'll show you too is, it goes back to, are you deploying something that you're not even going to be using? And I'm always of the mind of run the system, see what the benchmarks say before you start throwing additional hardware at it. So that's a metadata. So the metadata VDEV is another VDEV where it collects. It goes back to the many individual files where you have it's all the metadata, the date and time, the file size, all that information is stored on a separate fast disk. So when you're dealing with large pools of data where you have usually many files, that would be very handy to have. Dedupe, so deduplication. Does anybody know what deduplication is? So you can leverage a disk specifically for deduplication. So it's not, people kind of don't use it anymore because storage is, what's that? Yeah. Well, and it recently got sped up a lot. It got, there in one of the recent ZFS releases, it
I
got,
haven't played with it since they
yeah, it's something that's, it's unnecessary for the most part, unless if you're dealing with like really big stuff. And then reviewing it, and then you create your pool. Excuse you. Creates the pool. Do, 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 do.
This is the perfect thing for summertime. Get your pool ready.
Yep. It's summer,
That's right.
almost.
Oh, it is.
It feels like it.
Feels like it.
Pretty nice for 80.
Yeah. All right. So there. We finally got through that slide.
Did you backed out your presentation?
I guess so.
Now I wanna know about Australia shooting koalas out of trees.
What?
Oh, one of the things.
I'm sure it's to treat them for syphilis.
I thought it was chlamydia.
Or chlamydia. Yeah, one of them.
Save that story for the bar.
So we're gonna do this now. So data sets. So now that we've created a pool, now we've got to create a data set. Previously, I had stated data set is basically like individual file system. And what you can do is you can say everybody's got their own way on how to tackle their data organization. Like what I'll do is I'll try to figure out I'll try to create a single data set, and then you can create a data set within a data set. Which is really, it can be beneficial, it can work, or it can work against you, because one of the really cool things with ZFS is that you can send data from one ZFS pool to another ZFS pool, or from one VDEV over to another VDEV. And so if the data is all in one big data set, then you can just send it right over. But also at the same time, if it's in one big data set, then do you have enough storage on the receiving end to get it all?
So are the data sets different than like files and folders?
Correct, because a data set is a file system. Then once the data set's created, then you can create individual files and folders. So even just within
Partition.
correct. So even just within a if like I can drop down to a command prompt to a terminal in TrueNAS, and I can go to /mouse/tank01, do an ls. I'm not going to find anything. I'm going to find tank, but I'm not going to find any data there yet until I create the data set. And so when you create data sets, there are two, there are two things I'm trying to figure out. So there are, oh my God, I'm sorry. So there's a data set which creates individual files, creates the file system for individual files. And there's what's called a ZVol. And a ZVol is block storage. So block storage being, if you want to run a virtual machine, or if you want to run iSCSI, you want to run an iSCSI target. iSCSI is block storage. It's and so you can create those using the ZVol functionality, and it took a while for me to wrap my head around it, because I was like, oh, I could just drop down to terminal and look at what the data looks like, and what my iSCSI data looks like. No, it's not that at all, because it's how those protocols work. It's one big block storage. It's representative. You've got to be able to get into that block storage to actually see the individual files. So
So where would you say like logical volumes fit in all of this?
like a partition, like a drive being partitioned. I mean, probably you could say it in data sets, or
Like you create logical volumes across multiple drives.
yeah. That's probably simplest way or best way. It's really, it's not easy.
Yeah,
It's-
I'm just like, I'm like thinking about how you're talking about the data sets. And it seems like it might be a similar concept, but maybe a different way of
Yeah,
doing
because the cool thing about, like I was saying about data sets, is they're individual file systems. So they are a logical drive, you could argue. You're gonna set your own record sizes, unique record sizes to every single data set based on your needs. When you go through the wizard, you'll be able to leverage, when you create a data set, it'll ask you, hey, do you wanna apply a preset for generic or SMB share or hosting apps or what they call multi-protocol? If you're gonna host, if you can share out a single data set to be an NFS and SMB share, which is really nice. You might, your permission structure is gonna probably be a little screwed up, but it's entirely possible. I'm just starting to learn NFS myself. I never had a need for it until now. And I'm like confused, to say the least, because there's like no authentication. I'm like, unless if you're running special versions of NFS. So yeah. So, so in this case, what I'll do is I like to name my data set network shares, because that's what the data that's going to be in it. Or I'll name one like VM, like virtual machines or something like that. And then I had initially applied and then I'm creating another one called Colby's data using the SMB. And so from there, you're able to create a share with a data set within a data set. And then from there, you can create shares. So the share screen, it's very straightforward. You have SMB shares, your iSCSI shares, and your NFS shares. And it's not rocket. Oh, and so in the previous video, when I created this second data set, I had configured it as an SMB data set. And when it did that, it automatically created the SMB share. And then from there, I can go in there and edit the individual share permissions if I want to. And you can create groups and within the user manager and all that stuff, and do permissions.
So does TrueNAS run an SMB service essentially?
It does. Yeah, it runs an SMB v3 service, actually. You can downgrade it to you can enable v1 if you need to. And it can join Open LDAP and Windows domains. So that's obviously, like, from a bigger picture, trying to actually use this at work, that's how you're going to end up using it from a user management perspective.
The newest version now supports Kerberos, doesn't it, also for authentication mechanisms?
I think so,
Yes, it does. Well, last like 2 years, I've been able to use Kerberos on it.
yeah. Yes, it's in the settings.
Are you limited to one share per data set?
You can create multiple. Because when you create a data, within a data set, you can have, individual directories. And then when you create a share, you can create individual shares based on all those other directories within the data set. You don't have to share out a data set. That's just a common way to do it. As when you start getting into data management and things of that nature, you try to lessen the burden of trying to figure things out, but maintaining them. So in data protection is exactly that. You have all these various tasks to go in and protect your data multiple ways. You can, ZFS Scrub is a data integrity check. It's highly advised that you schedule those on a regular basis. It's just gonna do an integrity check on all your data at that given time, and it'll report out. You can configure email alerts or alerts of your desire. You can do snapshots. So if you've done anything with any kind of storage in big environments, doing snapshots, you can do snapshots in ZFS. You can store the snapshots within the same system, or you can send them to a remote ZFS location, which is really cool. So you can have like another machine running just ZFS on Linux, and you can send those snapshots over to that system, and then you can, and vice versa, and restore and all that stuff.
So you can just mount these snapshots, so you can mount any other file system?
Yeah, you won't be able to mount it. ZFS will be able to mount it.
But yeah.
And so actually, like when you send data, you actually are going to send a snapshot over. So like the first time you take your snapshot, it's going to be really big. Send it over, your data's replicated. And replication tasks, exactly what I just stated. You can do smart tests. You can configure smart tests. So again, as a way to make sure your disks are healthy, you can do long and short tests. They can take a long time based on the quality of the disk or the capacity of the disk. And you, again, have alerts set up to do that. rsync tasks, exactly that. Cloud Sync actually utilizes rclone in the backend, actually. So you can send data to your S3 provider or anything else like that. You can do that right through there, which is really nice. And then backup, True Cloud Backup Task. So they actually have a service called True Cloud. No, that's True Command. I don't know what that is. I've never needed to use, never explored it. They have a remote management suite called True Command. It's basically kind of like, it's WireGuard, it's management. They host it themselves. It's for a cost, or you can deploy it yourself for no cost, which is really nice. Network interface, really straightforward. Create your static routes. You can modify your IP address. If you are in an environment with VLANs, you can go ahead and create VLAN interfaces through here if you want to do that, or if you just want to manage everything through firewall. Change your name, all that stuff. It can do service announcements through MDMS and UPnP and all that stuff if you really want to. So, and this also has a firewall built into it if you desire to use it. Users, credentials, very straightforward. I'm not going to go into it. Instances. So with TrueNAS, with this version of TrueNAS, they are going to instances for VMs. So before it was KVM, and they've moved to this instances, or I forget what I think it's called, just instances. Sorry. I have not used it yet, and afterwards I will show you my system where I haven't actually upgraded yet. I tried upgrading last week and it went sideways, and I reverted back. One of the nice things about with TrueNAS is when you do an upgrade, it creates a snapshot of your boot, and so you can roll back really easily. So this is me creating a VM, really straightforward. Yeah. So this is all new for them. So before, containers were containers were supported, but in a different interface, actually through Docker. Now they have Docker and this, and I realized that my screen capture wasn't getting to far left. Real straightforward. We've all done this. So this is me going in, I'm specifying, so I'm creating a disk in a specific location that I created earlier.
So that's a disk within one of your data sets.
This is, I'm creating a disk for the VM, for the container that's gonna be stored in that data set. And actually, what I'm gonna create a specific data set within the other data, so I just created container disks. And then I'm creating another one called BusyBox. Because in my brain, that's how my brain works. I'm gonna create ones for it and then another one for the specific. And then I realize I'm doing this for all for naught, really. And then you have, information down there and all that stuff. So now we have apps. Really?
The quality. Yes, I realized that today at work. I'm like, oh, oops. Respect.
So they have a whole suite of apps, which if you're in the Synology world, it's the very same idea. It's just running Docker. Previously, so they manage their own catalog. There used to be a third-party catalog out there called TrueCharts that doesn't exist anymore. But you can go in and fire up your own local instances. I use this to on my home setup. I use Open Web UI to run local LLMs with a GPU. Through this interface right here, you can go in and you can, if you have NVIDIA or Intel GPUs, you can go in and check mark that, installs the drivers, and then be able to leverage those GPUs for those individual tasks, which is really nice, versus having to handle all kinds of other crap with that stuff. So, I gotta set a password. And just like that, you can have Home Assistant running at home. It's pretty, it's come a long way versus having to. I've never been a fan of like running additional services on like a storage, because the way my brain thinks is my storage should just be my storage. And so it's been a bit of a curve for myself to understand that no, it's okay for it to do more. I'm not a big fan of it. This is it running. So this is all Docker in the back end. You can actually, I want to say if you go up to configuration, you can actually just get a blank Docker config file, and you can just go in and just paste in your own Docker config, and which is a new thing for them. When it was running Kubernetes, it was really locked down. This is a system. real straightforward stuff. ZFS stuff. So that was the conclusion of my talk. Really abrupt. When I started going down this road of this talk was going into ZFS. That's when I realized I was like, I need to pump the brakes. So I've got a couple slides on ZFS if anybody wants to see it.
Yeah.
So ZFS stuff. So open ZFS. ZFS was started by Sun Microsystems. In 2005. Zettabyte file systems, people call it ZFS, whatever. So what I touched on before, a lot of people say, oh, there's this whole myth of, not myth, but somebody once said you need, a ZFS developer said you need 1 gig, you need 1 gig of RAM for every terabyte. That's not necessary. It's really unnecessary. And you need ECC memory. You need ECC memory. No, you don't need ECC memory. Very rarely do you actually ever have data corruption. And when you do have data corruption, can you really, is ECC going to help? You don't know. Did you get data corruption because you weren't running the ECC? Or did you have ECC and get data corruption? You don't know. You just don't know. So
Correlation doesn't equal causation.
right, exactly. What
The DDR5 now has ECC kind of baked in, it has 1 bit ECC.
right in DDR5.
Yeah, it has
Yeah.
1 bit ECC.
Right. Yes. So what does make ZFS unique? What you touched on earlier was it is software rate, which is great. Before, I remember in the NT4 and Windows 2000 days, the software RAID was taboo. It's not taboo anymore. Our processors are fast enough. Our RAM is incredibly fast. We don't need to leverage a single PCIe card to do all of that with special controllers and limited RAM. Let's leverage the system. The systems are incredibly fast now. What's up?
So the way I understand it, like you actually don't want to use RAID like that at a hardware level and use this kind of stuff, right? Like you want.
It depends. It just depends. I think on the situation, what you have available to you, what's supported and what's not. A lot of the traditional RAID controllers that we knew in the 90s and the aughts have, for the most part, gone away, except for unique situations. But even like large SAMs are largely software based.
So they don't use like a hardware.
They're not. Yeah, they're not using hardware RAID controllers anymore. They're using usually an HBA. So the cool thing is a lot with ZFS is in the ease of use to it through TrueNAS and just through the development in general. The aftermarket for HBAs is very good for if you want to get into this. So an HBA is a host bus adapter, which gives you more SATA ports or more SAS ports for your system, leveraging PCI Express. So you can throw in a 16 port HBA and have 16 additional SATA ports. And often what those HBAs are old RAID controllers that have been reflashed to only be a host bus adapter. And the batteries have been removed. The RAM's been removed if there was RAM on it. And so all those things, and so you can get HBAs for as little as $50 now. They're not going to be the fastest things in the world, but if you need that additional space, you can make that happen. So like I was, makes it, the accessibility of it has made it of all those components have made things a lot easier now.
So thinking about the hardware versus software RAID, imagine if you're running, like in my mind, this is where it goes. If you're running RAID Z3 and you're running a hardware RAID 5, now there's two different like parity checks. That are
Well, you're
trying
gonna have 3 parity checks on your RAID Z3,
Oh, yeah, three on
and
your
then
RAID.
1 on your RAID 5.
Right,
so-
but they're not gonna understand each other.
Right, so are you talking about doing that all on the same set of disks?
Yeah.
You can't,
think that's
because
what-
because the RAID controller is going to, what the RAID controller does is it takes all of those independent disks and uses its software to make it look like one big volume.
Right.
To the rest of the system, to the rest of the computer. ZFS is gonna see one big volume and go, I can't do anything with that.
Right.
You want me to create a RAID, I can create a RAID, I can create a stripe, a 1-disk stripe if you want. And then, but in the end, what's gonna probably happen is that ZFS is gonna start complaining about the disk. Cause it's gonna be like, hey, I can't figure out what the serial number is. I can't run smart on the system. I can't run smart on it because the RAID controller has assumed all of that responsibility ahead of the software itself. So
So yeah,
That's-
running
and
both
so-
of those would complicate.
exactly, and so that's one thing that as systems have gotten significantly faster from the 90s, we're able to leverage that CPU horsepower for parity versus having this independent controller that's on our system that has slow MIPS processors doing it, right? So,
Makes sense.
so again, tunable to your environment. You can create block storage, individual file storage with it. So again, what I was saying, like your layout, you have your pool. What we ended up creating was one big VDEV because we just had 2 disks. If you have multiple, we could have created 2 VDEVs of 1 disk apiece. Or we could have created 1 VDEV with 1 disk, or with the 2 disks. Or when you have multiple, you start going down this path that can hurt yourself, is what I like to say. When you have multiple VDEVs in a single pool, if 1 VDEV fails, they all fail. There's no redundancy. So when that VDEV becomes critical and there's a drive failure, if you don't replace that, if that drive fails and takes out that VDEV because you only have 1 disk of parity, all the other VDEVs that are in that pool, it will go down, will be taken out.
But can't you stripe across VDEVs?
You can.
I mean, sorry, you can make 2 redundant to basically get an equivalent like a RAID 10.
So again, so what a VDEV is, think of it as an individual RAID set. So you can have multiple, so to go back, you can have multiple RAID configurations in a pool if you really wanted to. It's not advisable. So you can have,
Yeah, you could have multiple RAID configurations in the same
Yeah,
pool, but now your software's really gotta. figure some things out.
you can start running into what's called an asymmetrical VDEV or asymmetrical pool. So when it's writing data, it's not doing it consistently at the similar speeds, and other drives will be waiting for other drives to complete their tasks when you could just put them in separate pools. Right. And that is what I have.
Is ZFS copy on write?
It is what's called COW, copy on write. So
You can turn it off.
can you?
Yeah, you can go to async mode and you'll get really fast speeds. But then if you like run into iSCSI, that's sometimes what I'll do for VMs I don't care about.
Okay.
But you lose the data security of COW, right? But if you really care about speed, don't care about what's in those
Yeah.
VMs.
So this is my system at home. This is a Ryzen 5600X with 16 gigs of memory. This is, I mean, I wouldn't say as low as you can get. Obviously you can throw. I've seen people run old AMD FX processors, and it runs fine. So like right now, I only have 4 gigs to my read cache. I have 6.5 gigs for the one service that I run. Actually, that's services is all the ZFS related services, not just a cache, but also any apps you run. And then still, it's got 5 gigs of memory for 5 gigs of RAM free. I have 2 pools set up. So I have one. So Fast01 is SATA SSD, and Slow01 is a bunch of hard drives. And you can see all the data right there. You can see the last scrub, last scan duration is how long the scrub took, and you can see when it happened. Yeah. So when you better representative, so when you are looking at everything, you can see what other disks have been assigned to these specific tasks if you have them set up. And you can see when the health is, when your last scrubs were, just more granular information. When they upgrade TrueNAS, if there is an upgrade for ZFS itself, when you get to the screen, you can upgrade the pool. So when you upgrade pools, you run the risk of not being able to roll back, because that upgrade might make you incompatible to previous versions. So like when this new version just came out, I upgraded. Upgrade didn't go very well for me, so I rolled back. But I didn't upgrade the either pool before. So I was able to roll back successfully because I was still using a previous version of ZFS on the pools.
Right.
So it saved my butt. This is what my data sets look like. So that's just, everybody has their own way. So you have this column for roles, which is what, it just signifying what that is being used for, like SMB share, NFS share, things like that. And I have like Home Assistant. So I have Home Assistant backing up to it. I have Proxmox backing up to it. I'm starting to futz around with PBS, a Proxmox backup server. I haven't figured that out yet. So that's on my to-do list. Again, shares, more of that information. So, yeah. VLAN interfaces, what it actually looks like, and I'll show it. So reporting, so what I was saying before, when you start using this and you're trying to figure out what you can improve upon, leverage the reporting to figure out if you have bottlenecks, where you actually have bottlenecks. It's usually not in CPU. First thing I always say is go down to ZFS. People always talk about, disks are slow, it's not as fast as they think. Your cache hit is going to be, is the read actually coming from cache or is it coming from disk? And same with your ARC. So ARC is your read-only cache. This right here is, how big is your ARC? And you can see like it fluctuates. That's one of the really cool things that ZFS will do, is that people think, oh, it's just going to take up all this. It's going to always just be as big as it is. No, it's going to go up and down, up and down, up and down. It knows that it needs to release some RAM if something else is asking for it. So it'll fluctuate like that. And so when you're looking at this, you can see, are you exceeding your hit rates, or are you having a lot of hits or having a lot of misses on your ARC? Maybe you can benefit from an L2 ARC VDEV, so you can have that fast read cache as well. So, yeah, there's that. So I've got Open Web UI running.
not secure.
So this is, I have an A2000 in the machine and it just runs. So I don't use it I don't really ever use it much, but it's one of those nice things to have. It's one of those, it's learning going, oh, I can run LLMs. I can run it on my TrueNAS machine. That's weird. But I can actually do that. I can leverage the functionality of it, which is really nice. So yeah, so that's all I got on TrueNAS. Thank you.
Thank you, Colby.
Thank you, great job.
Sorry for the technical difficulties.